Hello. Let me put the webcam. Hello, everyone. Apparently, we are live. I think. Let me know if you can hear me. Okay, I think it's getting a bit delayed on LinkedIn. Okay, I can hear myself, I think. Then if nobody, it's like, works fine. Perfect. Thanks, Clemens. Okay. Um, welcome to our first community meetup, Qbeast Community Meetup. This meetup is intended to share news and ideas and just knowledge around the Qbeast Spark project. And we're starting this live stream. We had little problem with YouTube because apparently you need to wait 24 hours until you can stream for the first time. So that was a little bit tricky. But now we're all set on LinkedIn. Probably next streaming we can do in both platforms, hopefully. And yeah, that's it. I'm gonna present myself and just introduce you what it's gonna be this meetup about. Welcome, everyone. So in today's meetup, what we're gonna see, it's like an intro to the Qbeast Spark project. So those who didn't know, you will get like the highlights of it. We're gonna talk about the next release we are preparing, hopefully for before Christmas. It's the release 0.3.0, and we're gonna talk about the features that we implemented in that release. Also, we're gonna see what is next, what are the next plans, what are we working on currently, and on the end we have some Q&A. If you have any questions on the project, please don't hesitate to ask them in the chat, and I will check them up later and will come with helpful answers, hopefully. So who am I? First of all, nice to meet you all. I'm Paola Porto. I'm tech evangelist at Qbeast. I like big data, movies, and books. So if you have any suggestions on books and movies, they are also welcome. A little bit of my background. I studied computer science here in Barcelona in the UPC. And I started at Qbeast while I was in university. We started in the Barcelona Supercomputing Center. And after 2 years, we made this spin-off about Qbeast. We rebuilt all the technology that was developed on the BSC to be suitable to more cloud architecture. And I was really involved in that part, and that became the core technology of Qbeast, so the open source that we're gonna see today. So first of all, what is Qbeast Spark? Qbeast Spark is a data lakehouse format that enables multidimensional indexing and sampling on the lake. That sounds super cool and everything, but what does that really mean? So multidimensional indexes, it's basically we organize the data between the space that it's covered, and then you can filter by different columns more efficiently. So you don't need to load all the data to know, for example, data from Barcelona and about people from the age greater than 20. So if you want to know this certain subset of data, this multidimensional index will help you find that data instead of loading them all and then filter. And sampling, it's because we save a representative sample on each of those files, and we can just sample this percentage right away. We don't need actually to load all the data and sample the data. And this is helpful because if you want like to aggregate and do an approximate query, so for instance, you want to know what is the average price that your customers are paying, you don't need the answer at the exact position. You can answer the query with a certain margin of error. And for this margin of error, you can sample the data and get an approximate average of what your customers are paying. So the Qbeast format, it's based on Delta Lake format. It aids the certain metadata that helps us build this index into the commit log. And this is the output of the log. We see those files belong to a certain range of data. And under the Delta log, we will find the transactions that the table has received. And the transactions, it's basically, I added this file, I deleted this file. And in this Delta log will contain this metadata about the Qbeast format. So for more information, for more visual like understanding of what are those files and so on, this is the index structure that we have, this multidimensional indexing. Each cube is a region of space and will contain a representative sample of the data. So these cubes are actually the files, the output files that we have seen before. These output files here are actually those cubes in the tree. And these cubes have certain metadata that will be saved on the Delta log or Iceberg log or whatever other format log have. Later on, we're going to talk about that too. And each file will belong to one cube. So, for example, if we store like here in this, we want to know just the data, we want to filter the data that has the value A, we only need to load this file. This will be like the concept of filtering. But to know more about the whole indexing algorithm, the whole metadata information that we store, whatever, we have some academic courses on our webpage, so you can go straight there and just have all the knowledge in the blogs. So what is this meetup about? And the highlight of this meetup is that we are preparing the release 0.3.0. It's been a long time since release 0.2.0, and a lot of new features, like maybe not like huge amount of feature, but like really quality ones, because there were some aspects that we need to work on Qbeast, on the Qbeast Spark, that will leverage a lot of value to the format. So the first, we're gonna see like the several features that we introduced and some minor features that we did too. So first of all, that we are like so proud of, it's the table properties for Qbeast. So table properties will basically enable to query with SQL from not only Spark, but for other query engines. And these table properties are basically, you just need like to configure one single line of code under your Spark application that will like configure this Spark catalog to actually be able to create tables and insert into those tables with the Qbeast format, because the Qbeast format is actually like changing the way that the writes are performed, because we are like indexing the data and saving the records on one of the cube in one single file and so on. So we need to make Spark choose that implementation and write with the Qbeast format using SQL too. So yeah, these table properties, just add this, you will add this configuration. You can do in two ways. The catalog can be configured in two different ways. One is setting up as a default catalog. So as default catalog will process only the queries that will involve Qbeast, and the other ones will delegate to the in-memory catalog, whatever other catalog that Spark application has. And this is like the default one. But if you want to include like different catalogs in the same session, you can do too by like changing this parameter Spark configuration. So you put like a Spark SQL catalog, and on the last part of the configuration, you can do like for the default one, you will use Spark catalog configuration, and for a customized one, you can put whatever name you want. So, but be sure, because if you put this this customized name on the catalog, you choose to put several catalogs on the same session. When you write the table, when you create the table, you have to put this customized name as a prefix. So instead of creatable customers, here will be like creatable Qbeast catalog .default.customers. And this will allow Spark to process and call the right code, the right piece of code. So yeah, we have seen this create table SQL instance. So what is happening under the hood, just to give you a little bit of understanding of how we read and write the data. We first will read the data from this all customers table. That can be a route table, can be an aggregate, can be wherever. We organize this data into the cubes that you have seen before, this multidimensional indexing. We will group these records into the single cubes, and we will write the data of one single cube in one single file. So we achieve this one-to-one relation. And last but not least, we will, once these are the files written, so you to understand the ACID capabilities that we bring to the lake, this data lakehouse architecture. Once the files are written down, there's still, the readers cannot see those files still, even if they are physically there. They will only see it once they are present on the commit log. So the last step will be try to commit this information to the commit log. If it fails, this operation is atomic, so either will fail, either will be successful. And if failed, it will retry again the operation until it can be committed to the log. This is the table properties solution. And we have another feature that is the compaction, the bin compaction. So basically, when you append a lot of information to the table, you create, because you do like a small appending, ingestion, and stuff, you start to create a lot of small files. And this lot of small files can not be quite good for reading performance, because you need to read a lot of files. So open a lot of files on terms of network bandwidth and etc. It's not like really the most efficient way of reading data. So there's a solution for that it's called compaction. And in this case, the strategy is like being compaction, like grouping those small files into more bigger bins and then writing it down as larger files. So what we have to change, because we actually, in Delta, this is available from 1.2.0 version, I think. And we have like to change, since we changed like the way we write and we have these cubes and so on, we cannot like easily do traditional compaction. We have, because then you will like group files that are from different cubes and you will like destroy the whole index structure. So we need to also group those small files into the group of cubes. So yeah, that was basically the change that we did, and it's and it will be available on 0.3.0. Other small improvements include inserting to command, support for another indexing types. Before we're only supporting string and like numeric indexing, but since date and timestamp are also kind of numeric values, we added this support for indexing these kind of types. We also enrich some index metrics, so index metrics that you can check how it's the structure of your index. For that, we will like in another video, probably on another meetup, we can get more in detail of the index metrics and how to analyze it. But right now it's like just to know that you can do so. And also other bug fixes like some information we're missing or better filtering of the cubes and so on. So for this version, it's not already yet on the Maven repository, but the snapshot version, you can get access to it. You can, if you want to try, you only have to configure your Spark shell by putting this repository's parameter that it's the address of the Sonatype repository for a snapshot. So if you want to upload a package to the Maven central repository, you can do directly by putting the package and setting everything up. But if you want to like to try it before and have some kind of snapshot on there, then you just only need to tag the version as a snapshot and upload it. And then on the packages side, you will only need like to choose Qbeast Spark 0.3.0 slash, not slash, I don't know how to say this one in English, sorry, but snapshot, and then you're all set to start trying it out, this new version. Okay, so what's next? What we are working on too. So first of all, I have to say we are working on per file statistics. So per file statistics is basically statistics for each one of those files, but not only like Qbeast statistics, but actually for each of the columns. So mean, max of the columns, number of node values for some columns, and so on. So since we changed the way we write in data, this is a feature that is available on Delta 1.0.2.0. But since we changed the way we write in data, we kind of missed these stats for each file. So we have a pull request going on. We still need to test it out, and if you have any suggestions to work on this, it will be like super helpful for us. But the idea is we add the process to gather those stats while we write the new files and save them on the log. And we also need, this is an example of the stats, how the stats will look like. On this add file information, you will have stats here, and these stats have this structure. This you can find it in the protocol of file of Delta, and yeah, that's why, as I said, you can store like mean values and max values for each of these columns. But not also we need to like add this information to the files. We will also need to add the filtering part. So I kind of did in a naive way. So before right now, we were filtering according to the index. So we traverse the tree in a particular way and find the cubes and files that we need to load. But we were not like contemplating file statistics, this struct that you see here. But Delta already has their own implementation. So we're kind of doing both at the same time, more or less. We're kind of doing both and joining to see which files we will need to load, to being able to load only the data that you need. That's the main point of this format. So this is what are currently going on. And another part is that it's an idea, still need to draft and everything, but it's an Iceberg integration. So Qbeast is designed in a way, Qbeast Spark, it's now based on Delta Lake, but it's designed in a way that it could be pluggable and integrable with other existing formats. And not only existing formats, but also query engines, because now we have a Spark and we have Delta, but we can have Iceberg, we can have Hoodie, and so on. So this is like a draft view of the metadata. So since we're only adding certain metadata to these add files in the Delta log, we can also add this certain metadata on the Iceberg log, on the manifest data file. I'm thinking I'm getting it correct, but please don't hesitate to correct me anyways. So we're kind of trying to build this integration with Iceberg. I think for Qbeast to be interoperable with the different formats will be a nice way of enable this sampling efficiency and multidimensional techniques to any existing format. Yeah, so that's I hope we can came back with more information about the Iceberg integration, but right now it's just an idea and a wish for Santa Claus actually. And another thing, this is more like an algorithmic part or a strategic part of the writings. So we are exploring different strategies to append and optimize the data layout, because as we said, appending small data to table can create like a lot of small files that can affect the reading performance. But also the way we compact those files and we optimize those files, it's important to keep a good data layout. So keep a good data layout so you can read more efficiently. So this is not for today, because I think with half an hour more or less we will have enough of this first meetup. But we are kind of exploring different strategies of like reducing the penalty of appending small files and optimize it in the best way possible and the less harmful way possible. So this is kind of everything for this for my side from this meetup. Now I'm gonna go to the LinkedIn page and see if someone has any questions. Please let me check LinkedIn. Okay, so I didn't see anything right now. I guess you fully understand what I'm saying. But yeah, that's then we can like just close it here. Just make sure you can follow us to social media. You can if you're willing to collaborate, if you got any ideas that you think you can be beneficial to the Qbeast Spark project, please bring to us. I'm so happy to answer your questions, to help, or yeah, introduce you like to some call and introduce you to the project and the different aspects of the project, or the different questions that you may have. We can solve them by calling. Yeah. So feel free to ping me through Slack, through GitHub. Leave a star in your way. So this is kind of helping us to growth and really motivating us to keep going with this project. You can email also us info@qbeast.io. So follow us on Twitter at Qbeast underscore IO, or me in Paola Pardo at Twitter account. So very happy to have joined you on this first community meetup, and hope we can get another one soon in YouTube. Please, thank God. Bye. Have a great day. Let's see if I can close this perfectly. Bye.